Hello and welcome to the online webinar series organized by IEEE Student Branch, Acropolis Institute of Technology and Research. This is your host, Piyush Chandak, and today we are very pleased to have with us Mr. Suryakanta Nayak. Mr. Nayak is a graduate from JNTU Hyderabad. He has more than 9 years of experience as a verification engineer in prestigious companies such as Xilinx and Tessolve semiconductors. He has worked as a application-specific integrated circuit design and verification engineer. We are very delighted to have him amongst us. Now, I would request our speaker to kindly proceed with the session.
Uh, hello everybody, and thank you, Views, for the introducing me. And here today, I am very grateful that Mr. Lalit has given this opportunity to share my experience to the students. And I think here all the not only the electronics, communication, electrical, every branch is present over there. Right, so I can share. I have more than 9 years of experience in the industry of the VLSI, so I can share whatever my knowledge. I'm not presenting or so I just sharing whatever I have experienced during these 8 to 9 years, how I start the career, what are the problems I have faced, and how the students need to be taken care. So I'm not going to detailed technology wise. I can very simple things whatever the student can take care to get into this field. So many people right now after graduation, what they'll do, whatever the branch they are going for the software because easily available jobs are there. So every people will go for the software, but people are thinking VLSI means to get into the knowledge how to start is very difficult, really, because no colleges has giving that much of scope for the students to understand the path to getting the work in this VLSI field or semiconductor domain. So as a electronics, we have a very good opportunity field, but 99% are means debating to the software industry because of the easily available job. So,
Yes.
but yes, so I can give my experience that may I feel that may helpful others, because I am not the means IIT graduate. I am from the small college, and I do not have that much of career growth till my engineering. I'm not, so I can give whatever the problems what the student can get to get into the this field. So here, so I will start with my presentation right now. So so anything, please free to ask whatever the doubt you have. If you feel I can answerable, I can answer you. Otherwise, I can send. You can send me the mail. I'll give the mail ID at last. Here, starting also, I have the mail ID. You can give the. I can give the mail ID, so you can send me that mail. If I can't answer you, I'll reply you. Okay. Now we'll start for the presentation. So today my topic is just a step in semiconductor world. So this is, as I told, how to introduce yourself into the semiconductor world. So here below my mail ID, suryaindiamsemi@gmail.com. So you can mail me if you have any doubt. Okay. So the first now this is the goal of today's sessions. What I have prepared, this you can see, this is a very easy things like electronics and semiconductor world, how the electronics and revolution of the electronics, and what is the semiconductor world, how the semiconductor world is working, and how the chip is being taped out or release, how what is the procedure of that chip is going from the scratch level to the making a chip from front end, back end, what is that, what are the technology used, what are the ICs, what are the transistors. So those things we will discuss over here. Next is the overall VLSI industry, how this industry is working, and what are the type of engineers are there, and what you will do if something fault is will come, if anything problem in the chip will come, how they will rectify that one. And now this is the main thing for the student, is the skills to make in dark track, means how, what are the skills you need to pursue the career in the VLSI. So at the starting level, what are the skills you needed from the graduate or from the any masters. So what are the minimum skills you needed and how you improve yourself. I have few books, link of the books, not link of the some site and few books. So there I can show the in my presentation I can show you those things. And what are the scope of the electronics, uh, what are the companies here, and what are the government sectors also is there, how to get those things. So I can figure it out over here. So we'll discuss this. So next, so we'll start with the electronics and VLSI world. Okay, so what is mean of electronics? So can anybody answer it? Hello. Hello,
The
Pius,
participants, yes, sir.
are you able to hear me?
Yes, sir. The
Okay, okay,
participants can post
okay,
their answers in the chat box, and
okay.
we hope you
Yeah,
all would
yeah,
be
sure.
very interactive.
Okay, sure. So okay, so what is electronics? So in the simple word, electronics is the study of the electrons and method of controlling the electricity by using different component. So first of all, it is the study of the electrons only, electronics. How the electrons is moving, how to handle those electrons, that is the electronics. Now, previously we have the electricity already in our past, but how to handle that electricity in the miniature level was not there. So that electronics part is used to handle the electricity at the miniature levels by using it has the different component of electronics. So we can say the electronics has encompasses an exceptionally broad range of technology. So that means what, the electronics given the wing to the technology in the miniature level. So that is the when electrons come to picture, it became the all the technology like electrical and mechanical thing that became the faster. So it gets the wings. How that has been happened, we'll see few examples, few applications. So here, like embedded the embedded what electrons will do, embedded the intelligent to the electrical and mechanical component. So what, how it is happening, embedded the intelligent means it is giving the intelligent to the electrical as well as the mechanical component. I can give you one example. What is this? This is a our washing machine, older days washing machine. So in this washing machine only we have to put the cloth, and in other area we have to take the cloth and wash it. But it is totally a human, there is no technology, and there is no automation added here. When we embedded the intelligent, it does not have any intelligent, we have to take our decisions. But now this is a new updated embedded electronics, embedded electrical component. So it has the intelligent in it, it has the sensors. So because of that one, so it is now it became intelligent. So electrical component embedded with the electronics part, it is become it got the wings that it will automatically sense the timing, it will sense the water level, it will sense the our means how many weight is there, so everything, and if current fluctuation also it will handle. So those kind of intelligent can be possible when we embedded the electronics part into the electrical or mechanical component. So now this is the another example. So that is the kind intelligent given. Now with respect to electronics, we are giving the power to the technology. With respect to power electronics, how it is. So you can see one example is the car. Previously car has the normal handle steering, but now it is the power steering coming. Means you do not need to force yourself, you just tilt it, it will take care, and power windows are there. So those are can be possible with respect to the giving the power through the electronics. So there is few technology are there. The technology is the MOSFET technology, which is means the switching, handling the switching through the electronics. Instead of mechanical electrical switch, we are using the electronic switch. So that can be possible advancement of the electronics. Next, most important thing in our medical equipment. So now this advancement, after that medical treatment is means it is helping during medical treatment, and it is making the doctor's life easy. When you go for a doctor for early internal injuries or something, immediately doctor will let you know the which scan or what you need to do. So immediately he will give you that go for this check, go for that check. So when you do so that can be possible with respect to the electronics. Now our all the cancer operations and all the microcellular operations also can be possible with respect to the, instead of open heart surgery, there is also they are doing the laparoscopic things, and those can be possible with respect to the development of our electronics. So I can show you one video how the electronics is helpful in our daily life. That is a kind of interesting video. I can show you. That is not 100% applicable, but it is give us some idea how it is. Yeah. If electronics is not there, how it is there? How it is the life? Just a small example. Yes, from this video, what we got here is that if electronics is not developed that manner, then we have to think lot of we have to carry lot of things, like the battery problem is there, the start is there, and automatically it is how to start immediately. And when they are using the vending machine, it is emitting that that gas and everything. So that is and during the trimmer also, the person which is standing beside you have the problem. So those kind of issues we can face. Thus this is a simple example for that one. So that's why electronics is very important in our life to make life very easy. So now we'll go for the few how the revolution of the electronics. Okay, so electronics has begun with the invention of the vacuum tube. Previously they are using the transistors. So now electronics is so previously they are using the vacuum tubes. So now that has been started at 1897. So this is the example of a vacuum tube picture. So here what happens, there is a vacuum tube which has a cathode on the top and anode at bottom, anode at top and cathode at bottom. So there is a load. Load means it is a kind of any movement part, and a battery, and battery means electrical supply. Now what happens when the cathode has been given to the negative has been heated, then electrons as moving, it is electrons as moving, you can see the small dark spot over there. So that is moving from the negative to the positive, electrons are moving, and when electrons is moving here, then electric current will flow there. So from positive, then after that this load is moving with respect to this whatever the electricity we are giving. So this is used to control from the electricity for this load. So this is a kind of controlling mechanism they have started at starting. So that is a vacuum tube. So after that, this vacuum tube is also evolved a few more new technology, like this. The vacuum tubes are there. So instead of a vacuum, this vacuum is a kind of gas they are using. Otherwise, at low pressure, some gases, or it is a totally vacuum with a low pressure. Nothing will be there. So after that, they feel some drawbacks over there. So they have used some metal like tungsten, filament, those metals they have used. So this is the start of a transistor, we can say, the basic of the electronics part. Now the era has come for the transistor. So this transistor has been invented at 1948. So with this transistor has metals like germanium and silicon. Sorry. And this is the bipolar junction transistors. They have been, means you have idea like how these two transistors mean PNP and NPN both are been cascaded. Two junction has been cascaded. So that's why it's called the bipolar. Two poles are over there. So now after the transistor, so now the when they have combined the transistors, they made the circuit. So that is called the integrated circuit. That integrated circuit has, when that integrated circuit came to picture, then it is totally, electronics has totally changed the world. So that integrated circuit, after they have combined the transistors and make the ICs. So that IC, why that IC is so popular? Because of its low cost, low weight, and the size. And the size for that means single chip has multi transistors will be there. many transistors, so small circuits in that ICs to make the integrated those small circuits. Circuits is the combination of transistors. Those transistors making one circuit, and few circuits has making the one IC. So that is different technology they have been used. Slowly they have developed the technologies. So with the rapidly improves the technology, and they have moved to the transistor like FET and MOSFET and IC capability integrated. And when those ICs has been taken all the circuits, now the number of circuits, number of transistors will differentiate how the means what the kind of ICs are there. So now the ICs have been when they are using few circuits like 10 circuits, 10 transistors, then this is called SSI, means small small scale integration, and MSI means medium scale integration. There they have used like thousands of hundred of transistors in MSI, and LSI they have used the means 10,000 of transistors, and in VLSI they are using the 100,000 of transistors, means 1 lakh of transistors, more than 1 lakh of transistors. So after that ULSI has been, they used the around 10 lakhs, 30 lakhs, means 30 lakhs of transistors. There are 3 million transistors they are used. But yeah, I have highlighted here VLSI. So after ULSI is also present is come into the VLSI. So VLSI, after that VLSI, everything has been standardized, that whatever the transistors they are using more than 1 lakh, so that is coming, that will treated as the VLSI. That's why I have highlighted here. So ULSI is now is the part of VLSI. So more than 10, more than 1 lakh transistors come to the VLSI technology only. So they made it a technology. So for that they have how they are means making these ICs. So there is a different technology they are using, that is called a fabrication, means fabricate all the transistors into one small dense area, that is ICs. So they use the different fabrication mechanism like PMOS, PMOS, NMOS and CMOS. Okay, so now when we are talking about the ICs, so IC that IC will give will more powerful in the 1969 when microprocessor has been invented. That microprocessor has invented by the Intel, and Intel at that time. Morris, founder of the Intel, so what he stated one law. It is not the law. He given one statement. So according to the, but it is treated as the Morris law now. So what he according to his perception, the number of transistor on a microchip means any ICs, I can say any dense area, doubles every 2 years, though the cost of the computer is halved. So that means every 2 years, in the same area, the number of transistor will be twice. So that is the his perceptions. But now nowhere it is the twice. It is more than of 1,100 times, 100,000 more than that times. In if you compare to last year and this year, because every time the processor has been, every 2-3 months the processor has been changed, and now it is 32 bit, 16 8 bit, 16 bit, 32 bit. Only I am talking about the bit, but according to that, the number of in the same area, the number of transistor is also means multiplying. So now, and the technology becomes more powerful when the analog signals, analog processing added in the ICs. Now, previously, what the analog processing is the different part, but but slowly that analog processor, I think 1975 onwards they have added the analog processing into the chip. That means the single chip they have the analog processing like op amp, ADC, A to D converter, D to A converter, and digital part also. So those then this integrated circuit is became more powerful and more robust to use. So now the integrated circuit is so much intelligent that it has added the processor in it. So that is called the SoC. SoC means system on chip processor. So that system on chip, system on chip. So that means in a single system we have the intelligent like processor processing unit, we have the IOs, we have the RAMs, we have the logic blocks, and we have the ADC, we have the DAC, we have the IO devices, and we have the DDR RAMs, we have the Ethernet, and everything in the single chip only. And the single chip that is also not huge in size, that is also a handiwork, a handy in size. So that is the some evolution of the semiconductor means transistor, and now means how the electronics come to picture. Now we'll introduce here to the for the VLSI industry. So what is as I told that after the IC technology has once came to VLSI, after that all the ULSI, all the transistors come into the VLSI. So now in the VLSI industry, how this all the integrated circuit has been made, and how it can be from scratch, how it is, what are the cycles it is used to get all the process done to get a IC integrated circuit from the starting to the end. How the flow, everything we'll discuss here. So now there is two kind of ICs available right now in the technology. That is the ASIC means application specific integrated circuit, and another is the FPGA, field programmable gate array. So ASIC means, as the name says, application specific. With the specific application this integrated circuit has been made, only it will do that work only for that application specific. So, and the second example is the if you made a graphic card, then it will always act like a graphic card. So if it is a mobile processor, then always it can be that circuit, that IC is used only for the mobile processing unit. If it is a encryption block, then it will use only for that encryption block only. Next is the FPGA, field programmable gate array. This is that kind of ICs where one circuit, one IC has been made, but it is for flexibility of applications. Like that circuit can be used as a graphic card, and that circuit can be used as the encryption block. So how that the same circuit can be used? It is not the exactly same circuit. It is a fuse in that there is a big arrays will be there. In that some part can be used as a graphic card. When you program as a graphic card, that can be used. When we use as a encryption block, that can be the and other part can be used as the encryption block. So depending upon the user application, we can program it. So then it can be used as like your program, what you did the program on that one. So that it will understand how it is. So how the FPGA is there? So it has some logic cells. So predefined logic cells will there. Logic cells means what? You can see DFF means D flip flop. FA means full adder. It is just a logic block, I am saying. Then LUT means is the lookup table. So here means few mux. A lookup table means few mux. So when whatever so like these logic cells, there are thousands of logic cells will be there. So depending upon our application, we'll send the input in A and B, then and program it. Then that part will be treated as per the our application only. So we have to program it. But in ASIC we can program it. Once we made it, then it is done. but here we can program it. So this is a basic example of FPGA and ASIC. So how the FPGA and ASIC is there. So as I told, it is a programmable and it is the application specific. So as it is a programmable, it has the few steps are there. So so in the second point, what the steps is there, we'll discuss in the next slide. For timing, method timing, just keep it side. Now since hardware is already available, as I told that already one circuit is given, and we need to just the application, depending upon the application, we need to program it. So that's why the hardware is already available. So non-recurring expenses. So that means always recurring expenses is not there, not that much of highly cost. This one recurring expense is not there, but in ASIC it involves a recurring expenses. Why? Because only for particular application it is used. If something change in that application, few features has been changed, then it has to be from starting, it has to be designed. So that's why it is a recurring expenses are there. So because ever two region, it is time to market. Means immediately you just program it and send to the market. But here we can't send it because it is from starting. It has to be do from the from the zero level, from the scratch. So same FPGA can be programmable for different applications, but here application for application specific, the same cannot be programmed. And as I told that it has the big circuit. Among these, only few can be programmed in FPGA. So among these, so whatever area we are programming, we are using that one. Than that, using whole full circuit. So that means if for one application I have used that FPGA, then we are wasting the other circuits as well. But here ASIC, as we know, for particular application we are using, that's why there is no extra circuitry, unwasted extra circuitry present. So and here obviously FPGA, as we are wasting few circuitry, so it is very less number of use. And here it is also means use means for more application we can use ASICs. Means for more applications means but each application, each ASIC will be used. Each circuit, only one circuit can be used only for the one applications. So as the FPGA is the slower because it has to be compromised with the frequency such that many applications can be fit. But but ASIC integrated circuit only can be fast depending upon that applications. And next, if the slow application will come, then it will design for a slow ICs also. Now, how the ASIC flow is there. So how this flow from ground level, from scratch to the ICs, the output of that means how the IC is made. Everything, how this flow we'll see here. So here first is the here is the front end and another is the back end. So you can see here the front end and the back end. There is two part here. In front end, what are the cycles we are following, and in back end, what are the cycles we are following here. Those things we'll discuss. So so here in general thing, if we are making some integrated circuits, first this application means for what application this has this circuit is made. So that's why we need customers. So at that time there is few engineers will be there, that is called the field engineers. They will contact to the customers and what are the features then a customer needed. According to that feature, they have they have listed out those features. So according to that feature, after that it will come to the architecture. So and that architecture will design that. Before this, the field engineer do, before this operation, before the design specification, the field engineer will do the work, and they have the features and they have the applications. For that we are going to make the ICs. So after doing that, then here the design specification will come. So in design specification, they have the there is set of group will be there. So they will design the they will make first design of the means how this application, this integrated circuit will look like, means how many processors will it contain, how many logic element will it contain, how the what is the bus width in that ICs, and those things has been, and how much RAM it has to be taken care. So those things has been decided by the design specifications, and after that design specifications, then behavioral description is there. In the behavioral descriptions, it will give all the behavior, how it will behave with respect to the applications. So then we will, then RTL will use the Verilog or VHDL. Now that actually front end work will start from here in RTL design. There is certain very few people is they call the RTL designer. Those RTL designer will make whatever the architecture has been made. According to that, they will made the they will going to make the your applications with the help of the HDL, hardware description language, like Verilog or VSDL. They will code that one. After that, now another part is called the functional verification testing. This verification will going to test whatever the code they have they made. They whatever the code they wrote, they are testing this this code. This functional verification engineer will check this RTL. So there are 2 and 4 things. 2 and 4 the things will be going to be going to here and there, because when the RTL designer, when they code, they have not idea of all the kernel cases. So but here the functional verification engineer has to his role is to capture those kernel cases and finding is if any error present in the RTL design. So this will taken care by the functional verification engineer. And one thing, the designing, if any circuit is designing, is taking only the 30 to 40% of the total cycle, but this functional verification is taking the 60, more than 60% of the cycle. Why? Because means timing, I can say. If RTL designer, if we can say for the for 100% of time to allocate this total RTL and verification, if we will consider, then only designer will take the 30% of timing, and verification will take the rest 60% will take care of the verification, because verification engineer has to think each and every scenarios which is missed by the RTL's designer. So that is the so after that it is coming to the logic synthesis. So they are, after this logic synthesis, whatever the RTL they have designed, they have going for the synthesis, and in the synthesis they got the gate level netlist, and that gate level netlist is having the all the gates, logic gates, and the connection of the gates according to this actual design. And now this gate level netlist is coming to the again. After that netlist, also that verification engineer will do once again to test that gate list. That is called the GLS verification, gate level verification. So that is also done by the verification. If any issue find during this netlist, this is to be indicated to tell to the designer that you have to code such way that this whatever the error he find here, that has to be even passed. So even though this verification engineer has given 100% that this RTL is good, means 100% correct, but still there is some condition may come during the gate level that will be that need to modify it with respect to RTL designer. So RTL designer has to modify so that this bug find here, whatever the bug find here, that has to be even go through. So after that that one, then it will go for the floor planning and placement route. So there, what is the meaning of floor planning means, let's say we have a floor and here we have to place all our component in such a way that it has to taken care inside the floor, as well as the routing between the floor should have been sorry, as a routing between the floor should all the circuit, a small circuit should not take the more timing or path or any clocking delays should not be there. So that is handled during the floor planning as well as the routing. Next come to the physical layout. Then in the, this is also, this physical layout is, we can say, the placement. So after floor planning means we are planned and next place that areas with respect to this physical layout. After that also, after doing the physical layout, when we place the circuits or gates, so what we'll get, we'll feel that during routing, whatever the timing from one circuit to other circuit, the data coming from one circuit to other circuit may change. So with respect to that one, we need to give some delays over there. That delay is called thus what is the maximum and minimum delay will come to picture over there. And during the this from the one circuit to other circuit inside that integrated circuit, means in integration small circuits gates are there, right? From one gate to the other gate, how much time data has to taken to travel from one gate to other gate, that much of what is the maximum and minimum delay can be handled, that can be used in this verification. Again, we need to do all the verification to handle that delays also. That with respect to that delay also, mine that whatever the RTL designer had did, that has to be go through with respect to that delay. So that is also handled during the verification. If anything will fail over the here, then it will tell to the RTL designer, as well as the whole process will go once again like this. So that's why it is a means to and fro process. So again it will go to here and again do the floor planning, and parallel it will tell the RTL designer, and again verification means we can say the testing, and again go for the logic synthesis till everything has to 100% clear, then it will go to the fab. So here in this VLSI industry, even 99.9 percent is not allowable. It, we have to be 100% clear. It is the 100% bug free or error free. Even the 99% 9 is also not allowed, because in because once the it will go to the fab, then our actual integrated circuit has been integrated circuit will be made after the fab. So that physical part we can't do anything, we can't change. So that's why what we have to be means this to be signed off 100% with 100% error free, then only all the features, all the scenarios, all the corner cases has to be verified, then it has to go to the fab. Now after getting the actual fab means fabrication laboratory, so where they are doing that MOSFET and PMOS CMOS logic technology to make actually our whatever we have coded the front whatever we have coded, whatever our architect specify, that integrated circuit will come out in physical manner over after the fab. So now after from the fab, there is also a post silicon validation. Again, we are doing one kind of testing over there, that whatever we are expecting before the fab, is that that goal has achieved or not. Is it because of that during fabrication is everything goes well or not. So after that, that is called a post silicon, means we have already get the integrated circuit that is called a silicon. After the post silicon, we are doing the validation. So validation means here actual chip, actual integrated circuit is we are providing different test scenarios and physically parameters, our electrical parameters, physically connected the input pins, and we are testing that whatever according to whatever architecture, whatever the design specification, that has met or not. So if any problem we found, my mistakenly any problem, human error or happened over there, again it will go here. So what the thing now, till this point already we have the circuit. But again, what will do? That's why at a time there is no mass production. We have to produce only few ICs. That ICs again validate over there, and in that IC we found that yes, there is a bug. There is this is one error is left. We have not tested it, or this feature is not. Means we can't compromise this feature. Then we'll go to the RTL designer, and everything we have to be taken care and again given to the fab after rectifying that bug. So now after getting this, next at the time also we are going to check it. If that bug has been fixed, then we'll go for the mass productions. So after that, now packaging will start. In packaging means how this, you can see this black color cover, and whatever the pins connections, those will come into the packaging. Actually these are not the whatever you are visualizing, it is not the exact ICs inside this one. So this is only the it is the package and input outputs pins is making the making our, and how during this packaging what that each pin should be in the number of left side pin, number of right side pins should be matched, because when you fit into the PCB, it should not be, or it is inclined, and it should be durable, such that IC should not fail with limited change in of the surrounding temperature, pressure, something like that. So at the time, this packaging is also taken care to make the ICs safe and robust to use. So this is the flow of ASIC. So in the ASIC, for a particular application, we go through these steps. Means we can see here how many times this is to and fro process has been taken care. Next, we can go for the FPGA flow. The FPGA flow is the similar to the ASIC, only little change is there. So what is that? We'll see. Now in the front end, we'll do the same thing: design specifications, behavioral descriptions, architectural descriptions, and here the functional verification, testing, and logic synthesis. Everything also will taken care of all the things similar to the ASIC during the front end. So and we are getting we'll get the netlist also, and after netlist, what we'll do, we got the netlist. Next we are going for the placement, routing. As I told, we are doing the same. After that we'll get a bit stream means it is the number of 101010s. So that bit stream will be replica of whatever our whatever our RTL description, depending upon our RTL description or depending upon our logic gates, those bit stream will come to picture. So that bit stream is given to the FPGA. FPGA is, as I told, it is already a developed circuit. So I have designed something and I put into the FPGA to check that my design is working or not. Okay, now my design is working. Now, at this time, fab is, we are not going to the fab as before. We are going to the fab, but here fab means application has been made. One IC is there, but here in FPGA we have the ICs, but we are programmed that IC depending upon our applications. So if we want that IC to be treated as encryption block, then we have to program that we have to write the code of encryption block, and that will generate the netlist of the encryption according to this code, and we are placing that particular code in the FPGA in some circuitries in that IC. So only let's say it has the 100 gates. I use only 10 gates for this, for my encryption block. So only few part is used and rest part will be will leave as it is. So that's why we are not now. I have ready with my product. My IC has been means I can set my IC. So that is the help of the FPGA. Then immediately I have to do the RTL design, placement route, is any problem in the netlist, and here also to and fro will come after the get list. After the netlist, then we'll go if any problem is there. We also verify over here, and then after getting everything 100% result, we'll send it to the FPGA. And FPGA is not that much of cost because we have already the circuit already made, and we have just programmed to that one. So that is the path of the FPGA. So now we can see how the means FPGA is made our life somewhat easier, but we can't use always FPGA for the different specific applications. For mobile phone we can't use the FPGA because the FPGA is so some bigger in size, and it is not an unnecessary few unused circuit also is there. So for mobile application we want it will do only if it is a some means only particular for mobile will do only those particular applications. We are doing only for that particular application through the ASIC only we can do. We can't use mobile for the we can't replace it for the graphic card. We can't use it for the Ethernet. So we can't use because it is for a particular application only. The mobile has been made, so only it will do that. That's why we are going for the ASIC instead of mobile. Let's say in some radar applications, in our defense applications, so there we prefer for use to the FPGA. So in that FPGA, depending upon they have taken the FPGA, defense people, they have to program according to their application. They made it, and they will use the that FPGA because only that particular missile, that product is used. So only for one product we are going, all the process is it is not the means what is use of that one. For only for one missile we use that circuit only. After the second missile we use, let's say, second circuit. So for that one instead of mass production is not needed, right? Only one FPGA and one circuit is enough. So that's why they have programmed it, and they take the FPGA and they program it and they use that ICs. So if the place where we need mass productions, such like home appliances, there we can use the ASICs. So now all our washing machine, our TV, our fridge, our mobile, everything now they are using for the ASICs. But for the defense application, for the satellite applications, and for the our means aeroplane, and for the automotive applications, there we can use the FPGA. Like few high-end cars, so they use only those very high-end cars. They have the limited number of editions. For that, what is the use of mass productions? They use the FPGA. For that, they have to be used only for that. Only few the how much production is there, they will use those FPGAs, and they will done their work. So like that, our VLSI industry is changing day by day. Now the FPGA is also so robust that they are making the small FPGA, big FPGA. Those things is getting handled in FPGA also, so that it is work as like ASIC to with respect to their applications, with less number of to left the less number of unused space. Now FPGA is also then now company is making the FPGAs now in means like that our VLSI industry is growing, means such that it will reduce the workload and making more automation and low cost and less area also. So and now the less power is also coming to picture. So those things will advancing with respect to the VLSI industry. Now with respect to different technology, this is this is so robust. Now that is the industry we have discussed. Now we can see how to enter for a fresher, how to enter to this VLSI industry. What are the minimum skill set required to enter to this, to get into the VLSI industry, means semiconductor domain? So first thing, we have to know the digital design. So we have to thorough the digital basic blocks. What are the blocks? Gates, logic gates, you might know, AND gate, OR gate, XOR gate, basic blocks, flip flops, not blocks, sorry, adder, subtractor. So by using the gates, you are making the one blocks. So those are the base adder, subtractor, half adder, full adder. Those understanding of those things, and muxes and comparator and decoder, encoder, those blocks. Those are, I can say, the combination of the gates, how you can handle those gates effectively to make a block. So next is the flip-flop. This is a sequential element, means depending upon the timing element, clock is coming to picture. So here sequential element, a flip-flop sequential element means our basic blocks, gates plus the clock parameter, means timing parameter handling. So that is called the flip-flops. Now is the counter. So for that, counter is also the mixing of the our basic blocks and the flip-flops is called the counter. Counter means one counter will count from the 0, 1, 2, 3. Let's say one is the 16 3-bit counter. 3-bit counter means it will count from 0 to 7. 0, 0, 0, 0, 0, 1, 0, 0 in 3 bits. 3 flip-flops are used here, and it is in every timing, every clock when come, it will increment 1. So let's say I am saying 3-bit counter. So increment by 1 or 4, whatever your wish. So that is the with respect to counter. So we need to handle how these basic blocks and clock, we need to play in these basic blocks and clocks and counters and reset to get understanding of the basic digital design. Next is the obviously basic C language is necessary, because in future whatever the language you will learn, that will be the C language. With the basic is the C language. So now the our Verilog and system Verilog. So here Verilog and system Verilog is most important part of the way to enter to the VLSI. You need to learn the Verilog from how the test is how the counter has been coded, how the actual designer is coding the counter, how the verification engineer is coding the coding to handle that counter. So those HDL language means Verilog and system Verilog you need to learn. So that is not necessary for the much necessary for the VSDL, because everywhere in India, most 99 cases they are using the Verilog. So the Verilog, it is better to learn the VSDL, but if you are thorough with Verilog, then VSDL you can also understand. And in the system Verilog, it is used for the verification. So this is also a advanced version of the Verilog. So it has the more number of data types and more number of functionalities and more number of libraries compared to the Verilog. So it is the class base. So that we have to be strong in these two languages, Verilog as well as the system Verilog. So you can see a code of a counter as I told. So in that counter, what we are doing, we are taken a 4-bit counter. You can see input is the clock, reset, enable, and output is the count. Count means this counter will display the count, will give the count depending upon the AMR input. So here I have taken the at every pauses of clock means every clock is every once clock will come, then my counter will increment by 1 plus count. So if counter it is a input is from starting from the 0, if it is the zero raise type means the 0 means it will be increment 1 2 3 4, it will be the count till the 15 f means because it is 3 to 3 down to 0. So that's why it is the till 16 counts we are getting, because at a reset we are assigning 0 and next clock it will increment 1 by 1 1 by 1. This is the kind of how the counter is coded as the RTL code as the with respect to Verilog. By using Verilog language we have coded a counter. Now this code is going to the our synthesis, all the flow synthesis get level netlist, and after that all the placement route. After this, with respect to this code they are generating the logic elements, and with respect to that logic elements they will given to the they will placement and route, and that will go to the fab, and after the fab we will get one counter when we give the power supply and reset. After the reset it will count 0 1 2 3 till 16, and again after 16 if we continuously give, again it will come from the 0 1 2 3 till 16. This is next one. Methodology will be, now when you learn the when you thorough with the system log, you need to understand the methodology. So this is the methodology basics. So you all the students means who after graduation at least you have to understand the Verilog, system Verilog, and basics of the methodology. Methodology is nothing that is not that much of complicated compared to the system Verilog. If you understand the system Verilog, it has the few set of libraries, only methodology. That libraries, with the help of that library, that will easy our job. If we will code something in system Verilog, let's say means 100,000 lines, then in methodology it can be reduced to the 50-60 lines. So that is the help of, because already few codes, few libraries will be already designed, we'll just invoke that libraries. So that is the methodology. We can means you can have the understanding of the basics, so that in after when you complete your graduation, that will help to make you the job. So only learning is not important, means not enough for you to acquire the knowledge when you do the project, because learning is simple, you just learn and you will forget. So that's why you need to do one small project where you can use this Verilog, your system Verilog, or your methodology. So that is a very simple project that can be maximum of, if you will take to 5-6 files, each file has the 10-20 codes, 10-20 number of means maximum 50-60 lines of 5 to 6 files that can be used. So only to understanding how this methodology is working, how the system will log, how can we code it, so those things, how can we reuse things. So only the basics people won't expect, because with the experience of 5 to 10 years, also very difficult to understand these methodologies and system log. So means 100% thorough of this. So you just, as a graduate, just concentrate on the Verilog, and I can bet you that this Verilog and system Verilog is very easy. Verilog is very easy compared to other like Java, and even you will feel it is easy compared to C language also. Because it is such a nice thing. When you understand the logic once digital design, then it is just replica of the hardware to the in the how the human being is thinking, to design a counter, to design a flip flop, or to design a any block. So that is only, so you will enjoy it when you start learning the Verilog. So literally it is a very easy to understand the Verilog, but you need to means do some little project, some little code you need to write. So after this code, obviously EDA tools you need to be taken care. So you need to be checked, because everything is, you need to do the compilation. Compilation means checking whatever the code you write is correct or not, and according to the LRM, mean language reference module, means whatever the data types you wrote correct or not, you have follow all the procedure for that code. Means like you have not forgot to write the means the semicolon, or any spelling mistakes, or any declaration. Those things will do the compilation. And simulation means when you after compilation, when you actually run your give the input to the code, and code will give the output. That is called the simulation. When you simulate your code, when you will get work on your code, means whatever the device you, whatever the circuit you made, that how that circuit will behave, how to check the output after the simulation only. So that is the with the EDA tool. So there is few tools like Mentor, Synopsys, Cadence as providing the tools. We are just a few commands in the tools, like vsim, like vsim, vlog commands are there. Only we simple write those commands. That's it. So then the tool will taken care of everything. If your code is 100% compile clean, then it will go for the simulation. Otherwise, it will throw you error. And if your simulation, if everything you wrote correctly, then it will give the expected output. Okay. Now to get into the Verilog, first thing, use only this book, Verilog by Samir Palitkar. This is the what I say. You can go for the online classes, you can go for the other books for knowledge, but for as a fresher, do not. There is no need to go for any to understand Verilog any other books. Just follow this book only, Verilog by Samir Palitkar. This is the very nicely written, and everything you will find it in the only. I am talking about the Verilog only. Okay, so and the digital design, you can refer Ellie Morris any book, and by Borisman is also very good book. And but for the system Verilog, there is no specific those kind of books, because it is the recently developed additional means it is mostly used for the verification. So that's why that is not specific. You can go for the few online sites. There you can find lot of examples and a lot of very good very good descriptions also each and everything. When you completion of the Verilog, when you complete your Verilog, basic understanding of the, not completely, basic understanding of the Verilog, how to write a code, what are the syntax, how to how to make from the digital circuit to the code. If you understood the Verilog, then system will going to be easy. So you can refer these links, ASIC World. You can write down these links at the asicworld.com and testbench.in and learnuvm.com. So just if you Google it, other than this, if you Google it, learn Verilog, then you will find 100 of site are there. So go for, my suggestion is go for that site and try to in your when you are in BTech level, start because digital design only the basic things is not, no need for the third year student or fourth year student. When you will get the time, read those basic things of the digital design, start learning. If you are start learning the Verilog, then also few sites are there like playground, EDA playground. One site is there, EDA playground. So there you can compile your code, even the tools is not available, compile your code, you can check it. So slowly improve your knowledge in Verilog, and then first motto should be the digital design and Verilog. Then when you will feel comfortable in these two, then go for the system Verilog. And I can say one thing that before your graduation, if you are handy with the Verilog, system Verilog and basics of the UVM, then and if you have the project, small project, then definitely you will get a good opportunity in the VLSI field. And compared to other field, what I can say that VLSI field, you will get at starting you can't find the growth, but after let's say 2 years of experience or 4 years of experience, you can see how much growth you have. Means you, the pay structure wise, it is the one of the more in the high paying industry in the IT sector. VLSI is the one of the high paying industry, semiconductor domain. If some people is the same experience in market, they will get let's say multiple of 2, means experience. If the experience is 2 years, a multiple of 2 means 2 lakhs in India I'm talking. So he, if somebody is getting with the 2 years of experience in other field, they are getting 2 lakhs. In in VLSI field, they are multiplying of 3 they are getting, so means 6 lakhs. So definitely this is the one of the very one of the good high paying industry. And as a electronic, you can feel you won't get any time bored with this field, because every time technology is going to change. You have to be updated with the technology. Means people, what you are, people will think after 2 years you are working on that. What people will, let's say one Qualcomm processor is there, one Qualcomm is making one mobile phone, he is launching today one Qualcomm processor right now, but that Qualcomm processor is not decided right now. They have decided 2 years back already, and people worked on that. So the people, the other industry people, till the industry people know the technology, you are already master of that technology, and you will you according to the knowledge wise, you will be the I can say 2 years, 1 year more compared to the other peoples. So that is a kind of means experience I feel personally with respect to the this VLSI field, because in every domain electronics is used, and all the whatever technology will work. I can see that it is the VLSI is the means ahead of the market. Means to whatever thing come to market, you will be already have the knowledge before that market. So now this is the means whatever the scope for the electronics graduates. So in India, you can go for the government electronic sectors. All PCUs, you have the DRDO. There also VLSI is there, or ECIL, our any BHEL. Those things also there. Now the semiconductors companies like in India, lot of semiconductor companies are there, like Microchip, Intel. Intel is there, Xilinx, Broadcom, Qualcomm, Samsung. I think Apple will going to launch to come to India recently. Who will come? Apple, AD, analog devices, Micron, AMD, and Mentor, Synopsys, Cadence. Lot of product-based companies are there. That means they release the product. So that means they release that ICs, they release the FPGA, they release that ASICs. So and few service-based companies in India, that is Tessolve, Wipro, Cyient, TCS, HCL, Mirafra, and just counting on. And now it is very easy if you have 6 to 7, whatever I told, those four skill sets, then definitely you will get a good job at least in the service industry. So ultimately after the service, what I mean of service industry means they have to hire the people and they will place you in the product industry, but your payroll with respect to the Tissol, Wipro, Scient, and but you will work for the any of these product company, Microchip, Intel, Xilinx, ultimately, but there you are in the payroll of the service industry. So that is the means nowadays easily available VLSI carrier. But if you come down to 5 years, 10 years back, then it is not that much of easy to get a VLSI job, even though you have the skill set, because very less number of companies are there. But now you have the good number of companies, so you can plenty of jobs are there, and all are high paying, all are high paying. Okay, so and one thing is, as electronics, this is also embedded work is there. So embedded work means during the validations. So for that embedded, you need to learn the compile C languages. Those things also you have to be uh, taken care. If you go for the embedded, so that is the scope of every electronics graduates. So that's it. If you have any query, you can ask me. Yeah, that
Thank you
is
so much,
the.
sir.
Yes, thank you.
On, on behalf of the Acropolis Institute, I would like
Yeah,
to thank you for providing your precious time and valuable knowledge to our participants. I'm sure all the participants would be very motivated by this informative session. Now
thank you.
we proceed. Now we proceed to our Q&A session, and the
Yes,
participants are requested to kindly post their doubts and questions in the chat box.
yes.
Sir, the first question that I see
Hmm.
is um, it says that how should I choose and decide whether to choose a career as a design engineer or a verification engineer?
Yes. Yes. So as I told, in my slide, I have shown you that it is a means design and verification both are doing parallel things. So if you choose, there is no difference at the starting level. So you have to be, if you are interested for the, basically you need to learn for the digital design and Verilog and system Verilog. You have to learn these three things. Now, frankly speaking, as a fresher, when you enter to a field and when you recruited, they have recruited, so they will, if they have the design, you will go for the design. If you are interested to design after the 1 year of experience, if you feel no, I am not willing go for the verification, I am not finding any charm in the verification, then inside the company you can change it to design. That is not for 1 to 2 years. That is not, and design is quite of complicated. People will get handy design after even after 6 to 7 years also. So that means they are not doing the verification. They are doing the design, but they will support one of the good designer. Then designer will tell, do this thing, do that thing. Then slowly they will improve. You will improve your knowledge as a designer. If you feel the verification design is not, means you are not comfortable with the design, then go for the verification. But here it is not, means in the two area, in the verification as well as the design, you have to be the you will go for the all the knowledges. It's the same kind of knowledge you both have, because it is not like software that testing we have the manual testing or automated testing, and we are not coding. But here it is not like that. You have to be code. The designer, whatever the designer will code, you have to code same thing to test that thing. But your coding is somewhat different compared to designer. That will make your verification life easy. But you have the same understanding with designing as well as the verification. So for starting 2 to 3 years, I don't feel that if you will get the design job, you'll go for the design. And in verification in India, a lot of verification companies are there. Means you will get lot of work in the verification. You will get the easy job in the verification. And number of verification engineers required more, but you will feel the same, means the pressure, same kind of understanding as well as the designer as well as the verifications.
Yes.
You have to be code. You other than coding you can't do anything.
Um,
Yes, thank you for the question.
Thank you, sir.
Yeah.
The next question is, as a FPGA engineer, which
Hmm.
EDA tool one should you know?
So EDA tool, as I told, it is not FPGA engineer. It is a kind of what EDA tool are available and what are that, means those tools are, all the tools will be for the as I told, for the FPGA and ASIC. All will go for the same front end process, right?
Yes.
Front end process, as I told, that design specification, RTL design, those things. So those are all FPGA, and FPGA is nothing but a integrated circuit, right? It is
Yes.
also integrated circuit. So that integrated, it is a kind of, it is a part of the integrated circuit. It's a different type of integrated circuit, but all the elements only those gates are using. That means, so all the EDA tools, Synopsys, Mentor, like our Questa Sim, Multisim, Synopsys has the Cadence, has the ISU, ISU, yes, ISU, Xilinx has the ISE, Vivado. All the tools will be the, both for ASIC and the FPGA.
So every fresher should know a basic knowledge of all the EDA tools.
Yes, basic knowledge of the EDA tools. They won't expect you to ask. They won't ask you the EDA tools detailed. They will ask only when you compile. You need to know the compile command, right? That is
Yes.
vlog of that tool. Only one tool. If you use the Questa Sim, use that vlog is the only one compile tool. That's okay. Compile your file name. That's only that command. Two or three command you need to learn. Even I do not know the command, because when you come to the industry, everything will be the script. That command you won't write one, because lot of SOC means lot of blocks will be run at a time, right? So that times you just EDA tools only know small EDA tools, that how do we need to compile in Questa Sim, how need to compile in the, how need to simulate in the question. If you tell I know Questa Sim, that is okay. Tell two three commands. That's it.
Yes.
Only one EDA tool is enough.
Okay.
Yes.
Uh, so the next question is, any open source verification tools available for learning purpose?
Yes, there is a EDA playground. Name is the EDA playground. And in EDA playground, you can code yourself and you can check it. And I think for that, I guess you need, means for small thing, I think you need some, means email ID. You need to register it. Check it. It is available. Not
Sir, the next question is, how clock tree optimization will be done?
Clock
So,
tree optimization means,
yes,
yes, during the our backend process, so they have the different clock tree synthesis will be there. So there, what they do, they use the different kind of buffers and different kind of weights to optimize those clock synthesis things. So they use the different kind of buffers to handle those. Optimization means what? Optimization means correctly it has to be traveled, correctly it has to be placed everything correctly. So they are using some different kind of buffers to handle the clocks during those routing process. I can say during the routing process, during the, as well as the placements also.
yes, sir.
Yes.
Sir, the next question is, what is the function of tie high and tie low cells? The function of tie high and tie low cells.
Yes, tie high means it is the means tie high means it is I can say that when we are giving the voltage or during when I am giving the some voltage level, I am giving when I send the signal for that one. So
Yes,
it is tie high means it will be going to, if that threshold level in analog we can say try high analog concept wise, it will go to that high state means with that threshold level. After
okay,
that, if you will send the same signal with that less than that threshold level, it is come to the zero state.
yes,
Okay, that means if in between is there, because analog is the sine of kind of thing, right? Means it is not the fixed 0 and 1 you are giving. You are giving
yes,
one signals which cannot, which has the, who is, where is the amplitude or something. I can say just an example. So it will be going to, it will going to the high state, right here. Means if this is the threshold level, if it will come, then it will go to the high state instead of confusing which state it will go.
okay.
That's what I am
Um,
understanding, and my experience means that what I am understanding that. I think that will help.
Sir, the question says, can you describe how Verilog is different as compared to another normal programming language? So, what is its
Yes,
special characteristic? Verilog
yes,
is different as
yes.
compared to.
That's what I told. There is, it is not a programming language. First of all, it is the hardware description language, right? How
Yes,
the, it's a HDL. It is not a programming language. It is a HDL. C is the programming language. You can say. Okay,
it is used
which
for
one is
hardware.
hardware? It is for hardware. Means it has the syntax which is as like the hardware will behave. As I you told, as just now the before question is the try try
Yes,
one,
sir.
one, try high low, and it has the means it is looks like the programming, but it is not the programming language. It has the use that how the hardware will behave, how the hardware can be coded. It is used for that. The very like used for that one. You can't program anything, means automate it anything.
Okay.
Okay, only the Verilog after you have to do the hardware, and you do the verification. Then only when you do the hardware, you have to synthesize it. The synthesizable code you have to write. Synthesizable means the exact hardware can be possible. If you will write something which is the yeah, one loop, if you are writing one loop which will run for the infinite number of times, let's say, is
Yes,
that hardware possible? It is not possible because there is no hardware. It will run infinite number of times. It is not possible. So that we can't. But program language we can do. But hardware very
you
long
can create
we
that.
can do it. We can do it. But it is not the correct thing to do.
Yes.
How the behavior, how the real world, how the physical world you are, it will very long is meant for that one. How the hardware will be real hardware.
Uh, Sir, so this would be our final question due to the
Yeah.
limitation of time. The
Yes.
question is, what is the basic knowledge as a fresher that the basic knowledge a fresher needs to join product-based companies like Qualcomm? What are the expectations from a fresher?
Yes, that expectation is you have to be just I can say my first company was Xilinx. Okay, it is one of the Xilinx. It is also one of the means FPGA making company in the around the world. What is a big company? So when you go for the third year, by different number of syllabus, you will come to picture those things. Company name Xilinx. So there, what are the things you need? You have to be thorough with the digital design. You have to be thorough with the Verilog and system
Yes,
Verilog and UVM. UVM for the verification. If there is a design for fresher, they are expecting that, and they will not ask for the Qualcomm and this product company. They will not ask you detailed. They will ask for digital design detail because these all the digital design you have to be clear. You have to know the how the microprocessor architecture, your 8085 or 8086, that whatever the controller is there, how the controller, how the architecture is there, whatever the instruction sets is there, and those basics of digital design and microprocessor you should understand. Then Verilog, if you know Verilog very well, then that will means you will be means no one can compete with you. If the people will come now, people in coming to VLSA because they know the flavor of the VLSA industry. So there is a competition to understanding the, because every college is also providing the good knowledge of all this Verilog, SV, UVM. So you have to what you will do. You just start yourself to learning those, only those, nothing they won't expect from you to the depth level. They should know that you should know these things. Then what is the meaning of these data types, how this counter will work, those things. And if you know those things, then that if you have did one project correctly, let's say our some project I told you what, then definitely I will say, even if you are not placing in the means campus placement also if coming, then that will be good. If there is otherwise, even if within few days you can get a job in VLSI.
yes. Uh, Sir, there is a common query. So,
Yes.
some participants wanted to get the PPT. So, if you could share it with them, and
uh, okay,
they,
okay, okay,
yes, sir. Or
okay.
maybe some other ways to connect to you through your social profile, social media, or you mentioned your email.
Yes, yes. I mentioned my mail ID. You can send me the mail. In that I'll be
Yes,
available. And if anything you have, any questions you have, or anything to understanding the your digital design, some concept, if I can help, and I can help you. I mean, means it is wrong to say that to understanding 100% to the digital design, because like your syllabus is quite difficult. It will be difficult for me because in syllabus, in practical, it will be somewhat changed. Like so, in syllabus, some theoretical was I can't help, but digital design, if you have any doubt, any how to, and but Verilog, system Verilog, and UVM, if you have any doubt or if you want any help from my side, because I am working on this, so I have good means enough knowledge to share somebody regarding the these things. If you have anything, you can ask me. You can put me mail, so I can.
Sir, if you could mention your email ID, I will post it in the chat box. Sir,
Okay, 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 okay. Surya,
yes, sir.
Surya, 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 Indium, 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 Semi,
Yes, sir.
dot at gmail.com. That's it.
Okay.
So, and once again, I'm saying I am not a speaker or any lecturer. I just share my experience, what I feel. So there might be the many thing what I spoke with respect to practical thing that you may find in internet easily, and means if there is no depth of the how the CMOS or how the MOSFET will work, how those exactly in fab is going on. So that is just particular in theory wise you can learn those things. So what I share is only for the means what I experienced from last 8 9 years.
Sir,
So
I'm sure your experience and your simplistic approach would be very nice for the students, and they would have a lot of knowledge after this session.
okay,
So,
okay,
this finally brings us to the end of the session. I
yeah,
would thank our speaker again for giving his precious time and
yes,
all the participants who have been very enthusiastic. Thank you so much.
yes. Thank you so much.